Support vector machines classify data using geometry. Naive Bayes takes a completely different approach. Instead of searching for boundaries, it asks a simple question: how likely is this observation to belong to each possible class? Probability measures uncertainty. Before analyzing any email, the algorithm already knows the general proportion of spam and legitimate messages in the training data. This initial belief is called the prior probability. Naive Bayes examines the evidence inside each observation. Certain words appear much more frequently in spam emails than in legitimate ones. These observations estimate the likelihood of each class. Bayes' theorem combines prior knowledge with new evidence. The result is the posterior probability, the updated belief after considering all available information. Naive Bayes assumes that all features are independent of one another. This assumption is rarely perfectly true in real life, but it dramatically simplifies the calculations and often produces surprisingly accurate results. A new email arrives. During prediction, the model combines the probabilities associated with every observed feature. The class with the highest posterior probability becomes the final prediction. Training a naive Bayes model is remarkably efficient. The algorithm simply counts how frequently each feature appears within every class. That's the whole model. Count, divide, and apply Bayes' rule. It trains in seconds even on millions of documents. Let's recap. The prior is what we believe before seeing any evidence. The likelihood is how strongly each feature points to a class. Bayes' theorem combines them into the posterior, and the naive part is assuming the features are independent. Despite its simplicity, naive Bayes remains one of the fastest and most effective algorithms for text classification and probabilistic decision-making. It continues to power applications across communication, healthcare, finance, and cybersecurity. Naive Bayes predicts using probability, but another algorithm makes decisions in a very different way. Instead of calculating probabilities, it simply asks, who are my closest neighbors? In the next episode, we'll explore K-nearest neighbors.